Good morning, guys. This lesson today is a review to supplement the bond to energy POGL packet that you worked on last week. So it's just some extra notes and clarification if there was anything that maybe you had questions about in that packet that you worked on last week. You can also reference your textbook. This is in Chapter 8. I know we were working on Chapter 6, but I do like to pull this little section from Chapter 8 to kind of go along with Chapter 6. And we're only looking at a few pages, specifically pages 351 to 353. Also, you should check for feedback on your POGL, because I did look through those and make notations if necessary. So you should check that feedback that I sent back on the POGL to look for any clarification for anything on there. So in addition to using Hess's law or standard enthalpies of formation, we can also use bond energy to calculate the enthalpy of a reaction. So we have three ways that we could calculate those enthalpies of reaction. We talked about Hess's law, where you're given several intermediate steps and you determine an overall reaction and add the delta H's together. We also looked at standard enthalpies of formation, and that was where we used the tables in the appendix in our book to determine the enthalpy of a reaction. And the POGL that you worked on used bond energies, and you needed to know what was bonded to what element was bonded to what element, so you could determine bond energies and calculate enthalpies of reaction from there. And again, those bond energies are found in a table. There is a table in your textbook, and there's also that table that was in that POGL as well. So bond energy is the energy that's needed to break bonds or energy released to form bonds. So bond energy is just the involvement of bonds breaking and bonds forming, how much energy is being released or absorbed when bonds are breaking or forming. So that's what bond energy is. So just kind of a review, when bonds are broken, energy is added to the system. So anytime energy is added or absorbed in a system, the result is endothermic, which we've learned before. And so we will have a positive delta H for that. So a positive sign for energy. So what that means is delta H is going to be positive. So there, and again, I've referenced here that table from your textbook, page 384, has table 8.4, and that lists several of these bond energies for bonds breaking and for bonds forming. And also when bonds are forming, energy is released to the surroundings. So if energy is released, we know that the result is exothermic, and that means our delta H value is going to be negative. So that's just a little review of things that we've talked about before. And again, you can use that reference table on page 351 in your textbook. So here I put a picture from the textbook, and if you want to, you could screenshot it and you could keep it on your iPad. That way you wouldn't have to keep opening your textbook to look up those bond energies, but there they are, kilojoules per mole. I do want you to take note of one item on here, and that is the C double bond O, where we have that little asterisk, and so that asterisk takes you down to the bottom of the table, and I'll box this out. Anytime that you have the C double bond that's in the carbon dioxide molecule, the bond energy is going to be a little bit higher than C double bond O that would be in other compounds. So anytime you're working with carbon dioxide and you're looking at bond energies, you're going to want to use this 799 kilojoules per mole. And maybe any other time you're using the C double bond O where it's not CO2, maybe something like a carboxylic acid or other functional groups that would have that C double bond O, you're going to use the 745. So I just wanted to make that clarification on the table so you don't miss that and calculate incorrectly something with carbon dioxide in it. So this brings me to how we use these values to solve for the enthalpy of reaction, or delta H of reaction. So I want to just kind of highlight some things here. We're talking about a sum of energies required to break old bonds and add them to the energies released when we form new bonds. So delta H is the sum of bonds broken plus bonds formed. We know when bonds are broken that delta H is positive. So delta H is positive there. But we also know that when bonds are formed, it's exothermic and delta H is going to be negative. So you'll notice that I have that negative sign there. So anytime I am looking at this equation, if I have a positive sign, or I'm adding to a negative sign, that becomes, those two things combined becomes a subtraction. So what you can do is you can take the sum of the bonds broken and just subtract it from the sums of the bonds that are formed, and you can use this equation. And I don't know that that was really shown in the POGL that you did, so I just wanted to bring that to your attention, that you can use this particular equation for that. Now if you have your POGL handy and you look at numbers 16, 18, and 19 in the bond energy POGL, in number 16 you calculated the bond energies when bonds were broken, and you came up with obviously a positive 2237, and that's kilojoules. And then in number 18 you had to calculate the bonds formed, and we know that that's going to be negative, and that's 2316 kilojoules. And then in number 19, it wanted you to calculate the delta H of the reaction, or enthalpy of reaction. So if you remember, we're going to take the sum of the bonds being broken, so 2237 kilojoules, and we're going to subtract, so we're just going to take this negative sign, and it becomes that negative sign in the equation, and write 2316 kilojoules. And when I do that subtraction, I get negative 79 kilojoules. So you can double check that in your POGL. And again, I just want to highlight that this negative sign here is what becomes the negative sign in the equation that we used. Okay, so that positive and that negative sign that I showed you on the previous sign, we're just going to call it negative and pull the sign from the negative value in the bond formation. Okay, so I just wanted to bring that to your attention. Now I do want to do some practice problems from the textbook, just to practice, because in the POGL you did some practicing, but I would like you to do a couple more problems. In the textbook on page 384, again in chapter 8, I would like you to work on 53B and 54B and submit it as a PDF or picture, it doesn't matter, into the appropriate Dropbox. And that's due Wednesday at 11:59 for me to check. And just as a reminder, you are going to have a test on Friday, and we are going to have a Zoom review if anybody is interested on Thursday, and that is on the class page if you are planning to attend that session. All right, guys, that's it for today. Have a great day.